above the middle of the first third and is where the temperature should be monitored. Third form of heat transfer is radiation. Radiation is transfer of heat energy through space, in which a hot object is given up heat. For food application, infrared lamps are normally used to emit energy which is absorbed at the surface of the product. The factors that affect the heat transfer include the temperature differential between the heat source and the product, the length of the time heating is applied, and the medium involved. The composition of meat in terms of moisture and fat content also affect the heating rate. The thermal conductivity is the term used to express the rate of the heat movement through the material. The other term is specific heat, which quantifies the amount of energy required to change the temperature of 1 gram of material by 1 degree centigrade. Lean meat has more moisture, thus shows a higher specific heat compared to the fat meat, meaning that it needs more energy to heat up identical quantities. Heating whole poultry, cut parts or further processed products, sausages for example, can be done in regular convection or microwave ovens by immersion in water, providing the product in a properly packaged form, and by frying in oil. Various methods provide different rate of microbial inactivation, confer different textural and flavoral characteristics to the product. Choosing one method over another is commonly based on product identity, equipment availability, operation cost, government regulations. The two main objectives of cooking operation are to destroy food poisoning bacteria while reducing the number of spoilage microorganisms and to denature the protein, thus providing a firm texture. Canning. The canning operation, which achieves commercial sterility, is commonly accomplished by using a retort, that is large metal chamber capable of operating under pressure. The pressure is required to achieve the temperature above 100 degrees centigrade. Usually a temperature of about 120 degrees centigrade or slightly higher is used in retorts. This helps to reduce the processing time required to destroy the heat-resistant spore-forming microorganisms. Poultry products that are processed in such a way include canned chicken soup, chunks of chicken meat in gravy, turkey cubes with vegetables, and etc. The product is usually packed in metal can, glass jar, or flexible retort pouches and can be stored later at room temperature. The rate of heat penetration into the product is very important. The different type of commercial retort basically involve batch or continuous operation. In batch type operation, cans are placed in a large basket and lowered into a high pressure chamber which is then closed, whereupon the temperature is increased by injecting the live steam. In a continuous retort, the can move continuously through the equipment, in which a hydrostatic head pressure is produced in between two columns of water. This allows for a more efficient process and closer control over the conditions. The initial leg of the process is used to bring up the temperature of the product gradually before it is transferred into the steam chamber. Later, the last leg is used for the initial cooling of the product, followed by water spray and possibly dipping in a cold water bath. An essential step is to seal the can properly prior heating. Since high temperature causes pressure to build up inside the can, incorrect sealing or defect in the seam will cause leakage and ingress the external water or air, which will recontaminate the food inside. A thermal plastic sealing compound is usually placed in between the can and the lid, and it melts during the heating process so as to fill the space and provide an additional barrier. Glass jars are covered with a metal lid which also has a thermal plastic sealing compound. Retort pouches are composed of multi-layer, for example, aluminum foil and polyethylene, and one of them is thermal plastic material or coating, which become fluid on heating and serve as sealant. For a consumer standpoint, it is important to remember that when in doubt, for instance, in cases of swollen can or sensing of odor, canned food should not be consumed. Microwave heating. It is based on inducing friction between water molecules found in a food material. Lean meat has about 70% water. Since the angle between the two hydrogen atoms of water is about 107 degree, the water molecule is negatively charged at the oxygen atom and positively charged at hydrogen atom, thus forming an electric dipole. Microwave heating is attained by applying a rapidly oscillating electric field, which causes reorientation of the water molecules. The frequencies used in commercial microwaves are about 24,500 megahertz and sometimes 915 megahertz in US or about 896 megahertz in Europe. Microwave heating is not dependent on the thickness of the product. It is sometimes referred as heating from inside, which takes less time than relying on heat to be conducted from outside in a convection oven. The rapid rate of heating in microwave oven usually does not allow enough time for development of the browning on the meat cuts. Therefore, some new ovens usually include both microwave and convection process to speed up the cooking and provide that browning effect. Packaging material should be transparent in microwave so that transparent to microwave energy, but materials such as metal reflect the energy and result in arcing or spark as well as excessive heating of the material. Therefore, various plastics, glass and paper with low dielectric losses are commonly used. Infrared heating. This process employs electromagnetic radiation that is emitted by hot objects and is absorbed by the food. Infrared heating is less controllable and has a wider range of frequency than microwave heating. And in addition, the depth of penetration is lower and heat transfer relies upon the conduction from the surface to the interior of the food. The rate of the heat transfer depends upon the factors such as surface properties of the food and the temperature difference between the food and the heating lamp. Equipment used include halogens in quartz tubes fitted with electric filaments, ceramic heaters and metal heaters. The temperature of the heating element range from 900 degrees centigrade for quad tube operating at a medium wavelength of to 2200 degrees centigrade for heating lamp operating in a short wavelength range. Dielectric heating. This operates on a principle similar to microwave heating but at low frequencies. The food is passed between capacitor plates where high frequency energy is applied on the food by using the alternate electrostatic fields. Changing in the orientation of the dipole are similar to that involved in microwave heating. However, in this case, the thickness of the food is restricted by the distances between the capacitor plates. The main usage of dielectric heating in the meat industry is for thawing blocks of frozen meat and sometimes for cooking. Frying. The operation is used to heat the product to change the physical characteristics of the food and develop a brown or golden color on the surface, for example, to inactivate the microorganisms. The high temperature employed during frying operations is very effective in sterilizing the surface of the product, but it should be remembered that the internal temperature usually do not exceed about 75 degrees centigrade. Overall, there is trade-off between oil temperature and product quality. At a lower temperature, more oil will be absorbed by the product, whereas at higher temperature, the oil will deteriorate faster. This occurs by hydrolysis and later by polymerization of fatty acid and resulting in foaming, darkening and oxidation of the oil and oil and the product surface. If the product is only par fried at the processing plant, for example, a 1 minute treatment at about 190 degrees centigrade, for example used in chicken nuggets, it must be fully cooked by the consumer and food service operator. Fully cooked product at the plant are either eaten cold or only warmed by the consumer prior to consumption. Other preservation technique which we are going to discuss is drying. Drying of relatively thin slices of meat over fine or under the sun has been practiced since prehistoric times. The principle of this preservation method is based on reducing the water activity to a level that is too low to support microbial growth. Commercially dried product meat is used in dry soup mixes, dried foods, and for camping and food carried by the astronauts and to the outer space area. The most economical way of drying is by using hot air. For example, for this purpose, a small or thin slice of meat are placed on tray and are exposed to circulating dry air. Large meat chunks are not normally dried since surface hardening, that is, fast migration of water from the surface, can result in an unacceptable product. Freeze drying. This process is another way of removing moisture from the product while maintaining the original tray. The frozen product is placed in freeze drying chamber where vacuum is applied. Usually 1 to 1.5 mm of mercury. Ice sublimes from the product without passing through the liquid phase. In commercial freeze dryers, rapid sublimation is achieved both by applying a vacuum and rising the chamber temperature. While product is held on a colder surface, the product maintains its original shape because the water is sublimated while the product is frozen, and structural changes such as shrinking do not occur. Preserving the structure is desirable for product like soup mixes and for which rehydration is easier and faster following the freeze drying process compared to air dried product, and thus textural characteristics are better. The moisture content of freeze dried meat is usually 2% or less, and water activity is well below 0.6. It is very important to package the product properly and exclude all moisture and oxygen from the surrounding atmosphere. Some chemical treatments used for meat preservation are: first one is salting. In salting, sodium chloride is one of the oldest ingredients used to preserve meat. Preservation is achieved by lowering the water activity, hence reducing the water availability for microbial growth. In addition, a high salt concentration outside a bacterial cell can interfere with its metabolism since the salt draws the water from the cell. The salt concentration within a cell is around 0.9%. When the external salt concentration is about the same, the cell experiences so-called an isotonic condition. When more salt is added, higher external concentration result in in water moving out of the cell in order to maintain the equilibrium. This condition is known as plasmolysis, which can inhibit the growth and possibly destroys the cell.